HTML5 video elements. Up until the late 2000s and early 2010s, multimedia content on the web was for the most part placed in web pages by means of third-party plugins or applications that integrated with the web browser. Some examples of such software include QuickTime, RealPlayer, and Silverlight. At that time, by far the most popular way to embed video and audio on web pages was by means of Adobe's Flash Player plugin. Before HTML5, there was no standard way to embed video into web pages. A plugin such as Adobe's Flash Player is controlled solely by Adobe and is not open to community development. The introduction of the video and audio elements in HTML5 resolves this problem and makes multimedia a seamless part of a web page, the same as IMG element. With HTML5, there is no need for the user to download third-party software to view your content, and the video or audio player is easily accessible via scripting. As simple as HTML5 video and audio sounds in theory, it isn't as simple in practice. Several factors need to be considered before you decide to include HTML5's new multimedia elements on your pages. Although audio will be mentioned, I will be concentrating on the video elements of HTML5. First, you'll have to understand the state of browser support. HTML5 audio and video is supported in all in-use browsers, except Internet Explorer versions 8 and earlier. Many websites still receive some traffic from those earlier browsers, so you'll need to take that into consideration. Video container formats. Video on the web is based on container formats and codecs. A container is a wrapper that stores all necessary data that comprises the video file being accessed, much like a zip file wraps or contains files. Some examples of well-known video containers include Flash Video, MPEG-4, and AVI. The video container houses data, including a video track, an audio track with markers that help synchronize the audio and video, language information, and other bits of metadata that describe the content. The video container formats relevant to HTML5 are MPEG-4, OGG, and WebM. Video codecs. A video codec defines an algorithm for encoding and decoding a multimedia data stream. A codec can encode a data stream for transmission, storage, or encryption, or it can decode it for playback or editing. For the purpose of HTML5 video, we're concerned with the decoding and playback of a video stream. The video codecs that are prevalent to HTML5 video are H.264, Thera, and VP8. Video element and attributes. After exploring necessary business surrounding containers, codecs, and licensing issues, it's time to examine the markup of the video element and its associated attributes. Please note, the following examples are the minimum code required and will not be compatible with all browsers. The simplest way to include HTML5 video in a web page is as follows. As you can see in this example below, the basic for including a WebM video is as stated. Similar to the IMG element, the video element can also include width and height attributes. As you can see in this below, they have a width of 375 pixels and a height of 280 pixels. Even though the dimensions can be set in the markup, they'll have no effect on the aspect ratio of the video. For example, if the video in the previous example was actually 375 by 240 pixels and the markup was as shown, the video would be centered vertically inside the 280 pixel space specified in the HTML. This stops the video from being stretched or squished unnecessarily and looking distorted. The width and height values are always in pixels. No embedded video would be complete without giving the user the ability to play, pause, stop, seek through the video, or adjust volume. HTML5's video element includes a controls attribute that does just that. As you can see below, the controls attribute is at the end. Controls is a Boolean attribute, so no value is required. Its inclusion in the markup tells the browser to make the controls visible and accessible to the user. Each browser's is responsible for the look of the built-in video controls. The remaining video attributes are autoplay, which autoplays the element, used primarily in ad pop-ups, generally considered a bad practice unless there is a specific purpose. Loop, automatically loops the video. This can also be considered a bad practice depending on its need. Preload. This can preload the video and metadata in the background so it is ready when the user demands. There are 3 attributes for this. Auto, automatically starts the preload while the page is loading. This is done silently for the user and can help have the video and everything ready for the user when they need it for on-demand viewing. None. The video will not load in the background before the user presses play. Metadata. This preloads the metadata only without preloading the video. Poster. This places a single frame or a teaser in place of an icon for the video. It makes it easier for the user to decide which video to play. YouTube is an example of this in place. Many times, the teaser frame that they have in their videos will usually have nothing to do with the video itself. It is just there to try to draw in a specified crowd. Multi-format video support. Currently, there is no option to use a single container format to serve your video. To include multiple video formats, the video element allows source elements to be defined so that you can allow each browser to display the video using the format of its choice. These elements serve the same function as the source attribute on the video element. So if you are providing source elements, there's no need to specify a source for your video element. To achieve full browser support, here's how we'll declare our source elements. Here's your video MP4, video WebM, your video OGG. The source element takes a source attribute that specifies the location of the video file. It also accepts a type attribute that specifies the container format for the resource being requested. This latter attribute enables the browser to determine if it can play the file in question, thus preventing it from unnecessarily downloading an unsupported format. Source order. The 3 source elements are placed as children of the video element, and the browser being used to render the HTML will choose whichever container or codec format it recognizes, downloading only the resources it needs and ignoring the others. With our 3 file formats declared, our code will now look like this. As you can see below, here is the new codec, and also there is more information at the end to help it decide. You now have the information to enable your video to be viewed on all modern browsers. I have not covered the HTML markup for enabling pre-Internet Explorer 8 browser support using Adobe Flash. This will be covered at another time. Thank you for watching.